So the first question is, what do we know about a real image? Now, real images, if you think about it, let's just kind of do a little recap. When you have a converging lens, you have got points F and 2F. And I'm going to try use some color coding and put some F, M, and 2F over here. If I put my object at 2F, I get a real inverted image that is the same size at 2F. If I put my object beyond 2F, I get a diminished image between F and 2F on the other side of the lens. If I put my object between 2F and F on this side of the lens, they should all be the same size, I suppose, but anyway, I'm going to get an enlarged image beyond 2F. So those are all real images. If, on the other hand, I try and put an image at F, at least an object at F, I will get no image formed on the other side or anywhere, quite frankly. And if I were to put a object between F and the lens, I will land up with a virtual image on the same side of the lens. So, I've got three real images in this story. They're all upside down. They differ in size. Some of them are the same size, some are smaller, some are bigger. But they are all real, they are all inverted, and the definition of a real image is when my rays come and I have real rays crossing. But the definition is that they can be cast onto a screen. But let's just think about this diverging lens situation. With a diverging lens, no matter where I put the object, I am going to end up going in, across, and then dotting backwards, and then going through like that. So my image will always be virtual, and it will always be diminished. And it will always be upright. And it doesn't matter where I put that object on the same side of the lens. Diminished, and it will always be upright. So a diverging lens or concave lens is much easier actually to deal with. Some newsprint is viewed through a convex lens. So this is our convex lens summary. The print is held between F and 2F. So in other words, this peachy colored line. And therefore, the print is held there. The print appears, in other words, what sort of an image do I get? I get an inverted and enlarged image. The image on the eye, in the eye we get a small little image like this, okay? My object is always beyond 2F in the eye. Why is it beyond 2F? Because if you think about it, if you bring something very, very close to your eye, it doesn't focus. Why? Because it is not in the right position to be able to make a diminished image between F and 2F on the back of your eye. It's a real image again. So this blue line is the example of the eye. If you try to bring something closer to your eye than it's 2F, it just blurs. When an object 20 centimeters high is placed 50 centimeters away from a convex lens. So it's 20 millimeters high, that's nothing. 50 millimeters away from a convex lens. The focal length of that convex lens is 20 millimeters. So it would be 20, 40, and the object's been placed at 50. So I can look at this blue situation and say, I will therefore have a smaller and inverted image. Exactly the same as the eye, but not the same question. So it's inverted and it is diminished. When a 20 centimeter high object is placed 120 millimeters from a biconvex lens, the magnification is exactly 1. There's only one time when the magnification is exactly 1, and that's in this pink situation. Object at 2F, image forms at 2F. Which means that if I have placed this object 120 over there, that's 2F. So what is the focal length? The focal length for that particular lens would be exactly half of 120, which is 60. A camera has a focal length of 50 millimeters. How far must the film be placed to form a sharp object if the object is only 120 mils from the lens. So we know that we've got a focal length. Let's try different color here. Okay, so my focal length in this story, I'm told is 50. So that's 50. That means this is 100. And how far must the film be placed if it is to form a sharp image, and my object has been placed 120 millimeters away? So it's beyond 2F, which means that I would need to, this would be 50, and this would be 100. I would have to put my film somewhere between 50 and 100. The only option that was viable there was 75. They gave you 4 answers. One I think was 50, one was probably 100, one was probably 120, and the other one was 75. So there was only one answer that was between 50 and 100. You want to enlarge the negative of a photograph, which is 35 millimeters wide. And you're going to make a print 280. So what is the magnification? Magnification is image width over object width. 280 divided by 35. How far below the lens must the photographic paper be placed if the lens is 60 mils from the negative? So the object distance is 60, because a photograph you're making, you use the negative as the object and you create the image onto a piece of paper that becomes the photograph, which is the image. So when I rearrange that equation, I find that I get 480 millimeters, because the magnification can either be image distance over object distance, or image height over object height, or in this case image width over object